Okay, today's lesson is on solution stoichiometry, and as I promised you during the stoichiometry unit, that it never goes away. So we did regular stoichiometry, we did gaseous stoichiometry, and now we're going to do solution stoichiometry. So it's basically the same thing as regular stoichiometry, except we're not going to be given to in grams. We're not going to do gram to mole conversions in the beginning. We're talking about solutions, so we're going to have a volume and a molarity. So we've already kind of done this when we were doing this, learning what molarity was, but I do want you to recall that volume times molarity is equal to the number of moles, and then moles divided by molarity will give us the volume of solution. So we're going to jump right in this. We have only 2 examples to work today, so this will be short and sweet. Maybe not sweet, but at least short. Okay, so I look at my equation. It's already balanced. Yay. And it wants to know how many grams of silver. So this is what I'm going to be looking for. I'm going to be looking for that. Will be formed by the reaction of excess copper. That means happy dance. It's not a limiting reactant. If I had 208 milliliters of the 0.1 molar solution. So I'm going to start with the milliliters. I need to be in liters. So that's going to be 0.208 liters. I'm going to multiply by the molarity. Remember, molarity is the same thing as moles per liter. So that's going to be 0.100 moles of AgNO3 over 1 liter of solution. Okay, so my liters are going to cancel out. Now I'm in moles, so I can go to my balanced equation and see 2 moles of AgNO3 would give me 2 moles of silver. And now I've canceled out my moles of AgNO3. I'm in moles of silver. It wanted to know how many grams. So 1 mole is 107.87 grams of silver. So I just throw that in my trusty calculator and I get 2.24 grams of silver. Okay. Now this one gave us excess copper. So like I said, we do a happy dance. But if I gave you information about both of the reactants, then you would need to do a limiting reactant. In this case, I only have one reactant that's aqueous, so I couldn't do that. But if I had 2 things that were aqueous that were making a precipitant, you would just have to do that as a limiting reactant. So you would do it just like we did regular limiting reactants. We're just starting with volume and molarity this time. Okay? So then let's practice one going the other direction so you can know how to solve for volume. And that is same equation, but now I want to know, hey, what volume of the copper 2 nitrate, so now I'm going to be solving for volume, would be formed by these reactions. Again, excess copper, so same process. We're going to do volume times molarity because we need to know how many moles of the solute we have. So this is going to be 0.045 liters times the concentration of the silver nitrate, 5.2 moles of silver nitrate per 1 mole. I'm sorry. At the end of the day, I'm tired. Per 1 liter, my liters cancel out. And then I know that 2 moles of silver nitrate will form 1 mole of copper 2 nitrate. Okay, so I want to know volume here. So basically I need to get rid of moles. So the only thing I have left to me is this 3.5 moles of copper 2 nitrate per 1 liter of solution. So I'm going to put that on the bottom so I can get rid of it. 3.5 moles of copper 2 nitrate and 1 liter. And it doesn't specify here what volume, if I want it in liters or milliliters, so I would just leave it the way it is because that's what it's telling me. So that, when I do the math, would give me 0.033 liters. Or if I had asked for it in milliliters, multiply that by 1,000, and it would form 33 milliliters. And that's all there is to it. Okay? Like I said, if we were talking about 2 things that had aqueous solutions that I was mixing together, and I gave you information about both, then it would just be a limiting reactant, okay? Which by now we know how to do limiting reactants. And that is it. Maybe one of our shortest lessons ever. Look at that, 5:02.